Does this feel uncomfortable to you? Then I have good news. There is no reason to be concerned. This is highly repeatable and reliable. And I'll show you why and how. Do you feel you spend far too much time connecting and disconnecting fiber optic connectors with instrumentation? Then I'd like to share a few good ideas with you in the second half of this video. Stay tuned. Hello, I'm Stefan Loeffler, Product Manager for Photonics with Keysight Technologies. I've prepared a little repeatability test for you. I've connected a tunable laser source to a multi-port power meter and let both warm up and stabilize. I should mention that this tunable laser is highly stable and I've turned coherence control on to avoid interferences, just in case. For the test, I've also chosen a rather long averaging time for the power meter so we don't get distracted by noise. This is half a second. On the screen, you can see the power is moving below thousandths of a dB. I've known that for a while, and we're at 1.2 thousandths of a dB of deviation. Now let's keep that in mind. I'm removing the connector interface. And I'm reconnecting it. If I remember correctly, this is 2 thousandths of a dB that we changed the power. Now, how was that achieved? Let me show you a few details of this connector interface. First of all, these photodiodes are spring-loaded, so they move. And obviously, they form fit with the connector interface here. If I put that back on, it's even possible to move the connector interface a bit, the fiber, and I can do this now at our reference channel. So I'm moving this a little up and a little down, and we see the changes are really in the thousandths of a dB. Of course, I can press really hard, up and down. You can see in my finger that I'm pressing really hard. And that still moves only 2 thousandths of a dB plus or minus. Pretty reliable thing. If you ever try to reverse it, this will not work. They simply don't hold. So it's ensured that the position is correct. That is how stable and reliable this connection is. So no harm to remove it and put it back on. It is safe. So far I've demonstrated FC connector interfaces only, but there is more. Besides the FC connector interface, we offer the SC connector. This one. These are both 2.5 mm ferrules, but there are also 1.25 mm ferrules. Here we have the LC connector interface and the MU connector interface, both 1.25 mm ferrules. But there is also bare fiber. We offer a bare fiber connectivity kit for the multi-port power meter. It consists of this holder with 4 ports, snap on like the other ones, and then there are 4 of these bare fiber holders. If I open this, you can see how it works. The bare fiber goes into this holder like this. We close the holder and insert it in the bare fiber connector interface for the multi-port power meter. Then the entire 4-port connector interface goes and snaps on the multi-port power meter like the other ones. I've promised to share some ideas with you how to streamline the test and test preparation process. Think of it. This device under test for demonstration has just 4 strands of fiber. But if you're regularly testing devices with many more fibers, like 96 or more, then this gets really hard work to prepare your test setup. Why don't you separate your test preparation from the test? If you do so, you can prepare one device under test while another device under test is already being tested. Once you're done with the first one, just hook up the second one with a snap-on. If you found this video helpful, check out our optical component test products on Keysight's website. You find the link under the video. Thank you and goodbye.